So if, according to what you're saying we're skipping question 3, we're skipping question 4, and then we go straight to question 5. No? And then if we look at question 5, they're saying, in the diagram below, we have t. So we'll just highlight whatever it is that is given here. So we have t, which is given as the point x and 15. Now here they're saying you have your x, which is unknown, but you have your y. So the y value is going to be equal to 15. So we can come and construct a solid line like this, which is going to be perpendicular to the x-axis. So any y line which you construct is going to be perpendicular to the x-axis. So in other words, they're telling us this line here that I've just constructed is equal to 15. And then they are saying, okay, t is a point in the Cartesian plane such that OT, so they give us the length, look at this, from here to here. So from O to T, they're telling us that one is going to be equal to what? To 17. Yeah. And then they just said it's 17 units. They didn't say anything. So we'll write it as 17 units. And then they say we have P. Now here's our point P. Our point P, it's -2 and A. So they gave us the X value here. So we don't know what is X. We know what is X, but we don't know what is Y. Because remember, coordinates are given as X is to Y. No? Guys? Hello? Oh, you're still with us?
Yes,
okay.
Mr.
All right.
Yes.
So here, you have P. If you look at point P here, P is a point such that you have -2 and A. Now, if you have -2 and A, this is going to be another triangle. Look at this here. We can draw a line from P to the x-axis, and then it's going to form another 90-degree angle here. But now what are we given here? We're given X, not Y. Ne?
Yes.
So we don't know what is this Y. We'll come and write this as A. We don't know what it is, but we know what is there from here to here. So if they ask us what is that, they told us that is going to be equal to what? To -2. How do I know it's -2? I get it, this thing here, it's in a coordinate form. So it's X is to Y. X is to Y. X is to Y. So X is equal to -2. Y is equal to A. Here, again, we have X is to Y. X is equal to X. Y is equal to 15. Hence, I was able to do something like this.
Yes.
And then after that, they say we have K is a point on the positive x-axis. So we have another point here, which is point K. And then they say the angle KOT. So this whole angle here, again, we measure our angles from the positive x-axis. So if we go from here to here, we have theta. Now this theta here is applicable for both triangles. To make this question a little bit simple, let's do it this way so that you'll see what I'm talking about. So you have two triangles here. We have triangle, this one here with the red color, and then we have the other one with the blue color. So we'll start with the bigger one. The one with the red color, so it looks something like this. So here you have your T, here you have your 15, and then here you have your O, and then they said from O to T you have 17. And then this angle here, theta, is equivalent to the angle which is here, because we can use reducing angles to reduce it. So we can say this theta and this theta, they are exactly equal when we're using reducing angles.
Yes.
And then the other one that we have, it's another smaller triangle. So this one here. What does this one have? It has theta. It has P here. Ne?
Yes.
And then it has this as -2. And then with this one, we don't know what is the radius. We have no idea what is our radius. We have no idea what is our Y. So we'll just put question marks here. We don't know what is this. We don't know what is this one. Yes.
Why don't you put O, put triangle angle?
So we have O here.
Yes.
Yeah, so we have OP, and then here we have 90 degrees, and then here we also have 90 degrees. On these bigger triangles, what is it that we don't have? We don't have this one here. We don't know what is X.
Yes.
So now that we are done going through our statements, then we can go and start to work. The first question, it
Yes.
says calculate x. So we just want to know what is going to be x. Where do we find x? We find x on the bigger triangle. So we're going to use this triangle here, the bigger one here.
Yes.
Now you have y, you have r. So if you have y and then you also have r, then you can get x. How can I get x?
Yes. Using the theorem of Pythagoras.
So we're going to use Pythagoras. So if we use Pythagoras, we'll say we have r squared, which is going to be x squared plus y squared.
Y squared. Yes.
And then we know what is our r squared?
Yes.
It's 17 all squared, which is going to be equaling to x squared, which we don't know, plus 15 all squared. And then if you say 17 all squared, what do you get?
17. 289.
289. And then if you say 15 all squared, what do you get?
225.
So we're going to take the 225 and take it to this side. It says we're going to have minus 225, which is going to be given by x squared. We square both sides. If we square both sides, a square root has a plus and a minus. So if you type this in your calculator,
8.
You get 8.
Yes.
And then it says x is going to be equal to 8, but a square root has a plus and a minus. In the second quadrant, our x, is it positive or negative?
Negative.
So we're going to have negative 8. So we'll say, therefore, our x is going to be equal to minus 8. Meaning we can come here and say, on this diagram here, we can erase this and put minus 8. Negative 8. Yeah, let's check who else is here. I can see Muhau, are you fine now? Muhau? Offense.
Wednesday.
Are you good?
I'm experiencing network problems.
Network problems. Okay, let's continue with while we, but hopefully you can hear us. So let's continue with and then the first question says we should determine the tan of theta. Not theta. We're not looking for theta. We want to know what is going to be the trig ratio, the tan of theta. Now we're going to use our trig ratios, and then we're going to use SOHCAHTOA, which says we have SOHCAHTOA. So we're looking for 10. How would you define 10?
It's opposite all over adjacent.
So you have up all over the adjacent. Now, what is opposite to theta here? Let's look at theta.
50.
15. So we can have 15. And then what is going to be adjacent?
Negative 8.
Negative 8. So here we'll put minus 8. Let me erase this part. We no longer need it. So we know what is our 8 using Theorem of Pythagoras. So we got our 2 marks there for correct substitution and the answer. And then choosing the correct answer. So we'll say we have 1 mark and then using Pythagoras. So you give yourself 2 marks there. And then for this one here, you say you have 15 all over minus 8, not 8. So it's going to be 15 all over minus 8. You still find then? Okay, we go to 5.1.3. What is going to be the cos of 180 minus theta? Where do you find 180 minus theta? On which quadrant?
Second quadrant.
On the second quadrant, we can have 180 degrees minus theta. And then is cos positive or negative on the second quadrant?
It's negative.
So we're going to have minus the cos of theta. So we're looking for minus cos of theta. What is going to be minus cos of theta? So we have minus outside. How do you define cos?
As adjacent over hypotenuse.
What is our adjacent?
Negative.
It's minus 8 all over our hypotenuse. What is our hypotenuse?
17.
So we have 17 here. And then for this one, it's 2 marks. You'll get 1 mark for simplifying, and then you will get mark for substituting. And then if you say negative multiplied by negative, it's going to give you 8 all over 17. So you'll get a mark for the final answer, in fact, here.
17. Yes.
Okay, next one. We are looking for the sine square of theta.
Yes.
If we're looking for the sine of square of theta, we can write it this way. We can say this thing here can be written as sine theta all squared. Then we can look for sine theta. How do you define sine theta?
Opposite over hypotenuse.
So we have the opposite side all over the what there? Hypotenuse side.
Hypotenuse.
And then it says we're going to have, what is the opposite to theta?
15.
So we have 15 all over hypotenuse
Over
side,
17.
all over 17, but we need to square this. Ne?
Right.
If you square 15, it gives you 225. And then if you square 17, we saw that it's going to give us 289. But we can type it in our calculator, it's fine. Then we can say we have 15 all squared. Or you can type this like this in your calculator. 15 all over 17. And then it gives you 225 all over 289.
Yeah. Yes.
We still fine?
Yes.
Okay. Is the network better, guys? Muhau, are you back? Jane? Muhau, Basatsana? Network still a problem. Okay, we'll come back then, no problem. Now, the last one, we're looking for A. Ne? Now, where would you get A? On the bigger triangle or smaller triangle?
Smaller triangle.
So I'm going to get A in the triangle. Hello?
A.
So we have the small triangle. So we're looking for our A here on the small triangle. And then our small triangle, our A is the value of Y.
Yes.
So how are we going to get this? Problem. Muhau?
We are going. Yes.
Okay, let's move on. So we're saying we are going to use the smaller triangle. We're going to use the small triangle.
Yes.
Okay. If we use the small triangle, then we're looking for A. The problem is that we don't know what is our hypotenuse side. We don't know what is our A. So how are we going to do this? Ne? What we're going to do here,
I'm listening, Mister.
So you propose we do it in what way before I tell you how we're going to do it?
I have no idea.
You have no idea. Ne? But
Yes.
you see, the two triangles, what do they have? What do these two triangles have in common?
90 degrees and theta.
They have 90 degrees and what? And theta. Ne?
And
So I'm going to use theta into my advantage. Because they have something in common, which is theta, I'm going to use that into my advantage. So what am I going to say here? I am going to say I can get the tan of theta of this one. Why am I choosing tan theta? Is because it has what is given and then what I'm looking for. I'm looking for A. Ne?
yes.
So I'll come and say to them, but now the tan of theta using the smaller triangle. The tan of theta of the small triangle is going to be given by opposite all over the adjacent. Again. So
Yes.
what is opposite to the small triangle?
It's A.
It's A. Ne?
Yes.
And then what is adjacent to the small triangle?
-2.
-2. But look at this. I know what is tan of theta from the bigger triangle. I got tan of theta. What is tan of theta going to the bigger triangle?
15 all over
15 all over -8. So here,
Yes.
I will come and say, instead of writing this thing here as the tan of theta, I'm going to write it as 15 all over minus 8, which is going to be equaling to a all over minus 2.
Yes.
Then I can solve for a. If I solve for a, how am I going to do it here?
Cross multiply.
Okay, cross multiply. If I cross multiply, the 2 goes there. It says that I'm going to have minus 2 multiplied by 15 all over minus 8, which is going to be given by a. If you type this in your calculator, what do you get?
Minus 2.
15 all over 4. 15 all over 4.
Mr. 15 over 4.
15 all over
15
4.
15 over 4. So we get
Yeah.
15 all over what? All over 4. So this is going to be our a. So we'll get